Welcome to the course Excelling with Mathematical Modeling. In this lecture, we will be talking about a different combat model, which is a guerrilla combat model or guerrilla warfare. Just a bit recall that this combat model were introduced by F.W. Lanchester, a British engineer. He used a simple formula, simple mathematical problem to predict the outcomes of the number of soldiers surviving in a battle during First World War. So, his mathematical models were built on the equation that the rate of change is equal to rate in minus rate out, where your rate in is the number of troops that is supplied and rate out is the number of troops that cannot take part in the war, either they are dead or they are injured or suffering from something so that they cannot take part. So, what is a guerrilla warfare? So, or guerrilla combat. So, unlike the conventional combat, in guerrilla combat there is no one-to-one confrontation. The troops were deployed in small groups and they are hidden. We use the word covert. So, often you have heard it covert operation, that means the small groups deployed and they are hidden. So, if the troops are large, they are more likely to get caught because then the enemy will always notice. And also, if the opposing army is quite large, there is possibility they may find this guerrilla troops. So, they have to be very careful. Being hidden, they have to kill the enemy. So, we take xt and yt to be the number of troops, xt for army A and yt for army B. The assumptions are the operation losses are neglected, there is no new reinforcement, initially whatever the troops present that will be present, and the final assumption that the combat loss rate of the guerrilla troop army is proportional to the product of the sizes of both the armies A and B. So, unlike the conventional combat model, in this case dx dt will be proportional to x and y. And why it is that? Because both the armies are not facing each other, they are in a groups and they are quite far away. So, their loss will depend on both the parties. So, that is why it is depending on both x and y. So, your differential equation in this case will be dx dt is equal to some minus alpha times xy and dy dt will be equal to some minus beta times xy. So, we start with dx dt is some minus alpha times xy, dy dt is some minus beta times xy. Your initial values are x0 and y0 and your alpha and beta, they are the fighting effectiveness coefficients of the army B and army A. So, this is basically for army B and this is basically for army A. Now, we have to solve this. In this particular case, we use the technique like this. You start with dy dx, which can be written as dy dt into dt dx. So, dy dt is minus beta times xy and dt dx is 1 by alpha times xy with a negative sign. So, this and this becomes positive and this is beta by alpha. So, if I cross multiply, I can write this as alpha dy equal to beta dx, which implies beta dx minus alpha dy equal to 0. And then I integrate. This will imply beta times xt minus alpha times yt equal to some constant. And at t equal to 0, you have beta x0 minus alpha y0 equal to constant, which implies constant is equal to beta x0 minus alpha y0 from here. So, you will substitute this here and you get a relation between x and y. So, if I do that, I will get beta xt minus alpha yt equal to beta x0 minus alpha y0. And this will give me the value of y or the value of x as beta x minus beta x0 minus alpha y0 divided by alpha. Now, you take any one of the equation, either dx dt or dy dt, which is equal to minus alpha times xy, and substitute this y, which will be minus alpha x. This is beta x minus beta x0 minus alpha y0 divided by alpha. This cancels. This is minus beta x square plus beta x0 minus alpha y0 into x. Now, you have to remember this technique. You divide both sides by x square. So, this will be 1 by x square dx dt equal to minus beta plus beta x0 minus alpha y0 divided by x. And here you substitute z equal to 1 by x. Then you get dz dt equal to minus 1 by x square dx dt. So, basically this whole thing is replaced by dz dt. So, you will get dz dt with a negative sign equal to minus beta plus beta x0 minus alpha y0 into z. We can rewrite this as dz dt is equal to plus beta x0 minus alpha y0 times z equal to beta. So, this is a first order linear differential equation, and I have to use the technique for finding the integrating factor, which is e to the power integration beta x0 minus alpha y0 into dt, e to the power beta x0 minus alpha y0 into t. So, you multiply this equation by the integrating factor and you get ddt of z times the integrating factor minus y0 into t. So, you have to be familiar with solving a first order linear differential equation, which I am sure you do, and hence I do not think this particular step will be understandable to you. So, ddt of this is equal to beta times e to the power beta x0 minus alpha y0 into t. If you integrate, you will get z e to the power beta x0 minus alpha y0 into t equal to beta divided by e to the power beta x0, beta divided by just beta x0 but alpha y0 into e to the power beta x0 minus alpha y0 into t plus constant. Now, at t equal to 0, you will have z equal to 1 by x0, which is 1 by x0. So, if you substitute that, you will get 1 by x0, this becomes 1, this becomes 1. So, beta by beta x0 minus alpha y0 plus constant. So, from here you find the value of the constant and substitute it here. And if you simplify, you will get your xt equal to x0 into beta x0 minus alpha y0 divided by beta x0 minus alpha y0 into e to the power minus beta x0 minus alpha y0 into t. So, in the similar manner, you can calculate this yt also, and your solution will be like this: xt equal to x0 into beta x0 minus alpha y0 divided by this quantity. In the similar manner, yt equal to beta x0 minus into y0 divided by this quantity. Now, we come to three cases. So, first thing is this particular quantity when it is positive. So, if it is positive, what you see from here is limit t tends to infinity xt. This you get as limit t tends to infinity x0 beta x0 minus alpha y0 divided by beta x0 minus alpha y0 e to the power minus beta x0 minus alpha y0 into t. So, as your t becomes large, and since this quantity is a positive quantity, this whole thing goes to 0. So, as this whole thing goes to 0, you are left with x0 beta x0 minus alpha y0 divided by beta x0, because this whole quantity then becomes 0. And this cancels and gives you a value beta x0 minus alpha y0 divided by beta. And limit t tends to infinity yt gives you 0, because now this quantity is positive. So, e to the power this positive quantity multiplied by t, as your t becomes large, this goes to infinite, and if this goes to infinite, that the whole denominator becomes large or goes to infinity, and hence your yt tends to 0. So, as t becomes large, your yt becomes 0. So, in this guerrilla warfare, army A wins. So, all you have to do is, when this is positive, you find the limit for large time, and you see that this gives a constant value, because this is positive, this is always greater than 0. So, you have a positive value for xt, whereas as time becomes large, yt becomes 0, and hence army A wins. Let us now look into the numerical solution, for which I will be using this Microsoft Excel. So, I have already have the page open, where you have this equation dx dt is equal to minus alpha xy dy dt is equal to minus beta xy. So, the numerical value which I have chosen is for x0, that is initial value of army A is just 50 and y0 is 200. This is the rates, and this is the basically the fighting coefficients, and h is 0.1. Now, so what you will be doing is, so if I just take t here, if I take x here, and if I take y here. So, once again this Excel, they works on the cells. So, I will calculate this formula for one of the cell, and this will work for all the cells. So, let us say you put it is equal to 0, this is equal to 50 initial value, and this is equal to 200 initial value. Just increase the font size to 20 and make it bold. So, this will be equal to, so first is 0, and I add 1 to each of them. So, the increment will be 1. So, let us calculate say around 90 of them, say 80. So, I make this font again to some bigger size, bold. Now, if I want to calculate this one, so I will calculate the values for one cell and drag to the next 80 or 90 values. So, this is equal to, I will be using this formula, and this is my fxy, this is my gxy. So, this is equal to x0, like you can see x0 here. So, x0 plus h is 0.1, but this is a constant. So, I will put a dollar sign here to make it constant. This is multiplied by, which is a star. So, multiplied by minus alpha, the value of alpha is this, again which is a constant. This is again a constant times x value, which is 50, and y value, which is 200. Bracket closed and enter. So, I get this value. In the similar manner, I will calculate this is equal to y0, this value, plus h, again this is a constant, multiplied by gxy, so minus beta times x multiplied by y, and don't forget to make beta as a constant value. So, I put a dollar here and a dollar here. Enter, and this gives some value. So, now I just highlight this two and drag it. Till 80. So, I make them large. Oops. Yes. So, if I now want to plot it, I just highlight the values and I go to insert, I go to this scattered chart and I click this one. So, you get the figure. So, let me now go back to the slides and start explaining the numerical results. Okay. So, I have this numerical figure here. So, again for some reason this alpha beta is changing. So, this is your alpha and this is your beta. So, I have my initial value for army A to be 50, which is here, and for army B to be 200, which is here. I have already checked that beta x0 minus alpha by 0 is positive, and you can see that initially, though army B has an advantage of quite a large number of troops, but their decline is quite sharp and they are decreasing, and at one point their number start becoming less than the army B, and ultimately all of them are killed or dies. Whereas this army B, their operation is successful and they maintain, there is a loss obviously, but they maintain some steady value. So, that is the advantage of this guerrilla combat model. So, if you are efficient enough and your strategy and fighting coefficients are quite good, you can kill a large number of troops for the on your enemy side. Let us take the case when your beta x0 minus alpha y0 is less than 0. We have the same equation. So, we start with limit t becomes large xt, and if you see that if this quantity is less than 0, means this is less than 0, with the negative sign this whole thing becomes positive. So, if this whole thing becomes positive, then this e to the power some positive quantity times t, it becomes infinite as t is infinite, hence this whole thing is equal to 0 and becomes infinite and your xt is equal to 0 because this whole thing becomes large. Whereas, when you come to the yt in this particular case, beta x0 minus alpha y0 is less than 0 and hence e to the power some negative quantity multiplies by time, this goes to 0 and hence this whole thing becomes 0 and you are left with this into this. So, which is beta x0 minus alpha y0 into y0 by minus alpha y0. This and this cancels. If I put this alpha inside, so it is alpha y0 minus beta x0 divided by alpha, and this quantity is positive. Why? Because from here I can see that beta x0 is less than alpha y0 and alpha y0 minus beta x0 is greater than 0. So, I take it to this side. So, if this quantity is positive, then this quantity is the same positive quantity and hence as a whole this is positive because alpha betas are positive. So, in this particular case your xt is 0, your yt is a positive quantity. So, your army B wins. If you look into the numerical, you can see that in this particular case the strategy which the army with less number of troops they have taken, but they have failed. They are easily located by the army of large size and then all of them get killed, though there is a huge loss also for army B, but at the end they manage to win and kill all the enemies. So, that is how you have to interpret the results by looking at the graphs, and this condition has been satisfied for this set of numerical values. Our third case, which is beta x0 minus alpha y0 is equal to 0. So, in this particular case you do not get the actual answer when you substitute it here. So, what you have to do is, if you recall the equation dx dt when we were solving this, this is minus beta x square plus beta x0 minus alpha y0 into x. So, this particular thing is equal to 0. So, you are left with dx dt equal to minus beta x square, and if you integrate this, 1 by x square dx equal to beta dt, and this implies 1 by x equal to beta t plus constant. At time t equal to 0, x equal to x0 and your constant is equal to 1 by x0. So, if you substitute here, you get something like this, and this will give your xt equal to x0 by 1 plus beta x0 t, and we have your yt is equal to beta x minus beta x0 minus alpha y0 divided by alpha. This quantity is 0, so it is just beta by alpha times x, which is beta by alpha times x0 by 1 plus beta x0 t. So, again if I take limit t tends to infinity xt, then your t becomes large and this quantity is 0. Your t becomes large, then this quantity is 0. So, both in the large time your xt and yt becomes 0. If you take the ratio xt by yt, then that is going to be alpha by beta, a constant. So, they always maintain a constant ratio, and this is the case for tie or a draw. just like the previous discussion on conventional combat model. So, with this we come to the end of this guerrilla war tactics. In our next lecture, we will be looking into some more interesting model. Till then, bye bye.